the Southern Arizona Area Health Education Collaborative, and we are delighted this evening to have Dr. Fernando Martinez. Well, bring your attention to the introductory slide. The title of the lecture, and then the accreditation is by the SAHEC. Attendees are eligible to receive 1 hour of CME credit. To obtain the credit at the end of today's lecture, there will be a survey that is sent out, and that will be when you register to answer the questions as a part of that survey. That is how we know that you attended and how you will receive credit. So the financial disclosures for myself, I'm on the Speakers Bureau for GSK. One of the activity planners, Dr. Morgan, is a principal investigator with OM Pharma as part of the EAGLE clinical trial that LRIO participates in. And Dr. Martinez is a member of the Scientific Advisory Board for OM Pharma. And so Dr. Fernando Martinez is a Regents Professor at the University of Arizona. He's the director of the Arizona Respiratory Center. He's a good friend, an excellent pediatric pulmonologist, and we are just delighted to have him present today related to the giving us an insight into the hygiene hypothesis. So I will turn it over to you, Fernando.
Okay, thank you very much, Andrew, for the very kind invitation. It's a real pleasure to talk today about an issue that is at the center of the attention of the center that I direct and of many scientists all over the world. Let me see if I can here advance my slides. This is my disclosure. As was said before, OM Pharma has provided financial support for the completion of the Orbix trial that I will be talking about, and I'm a member of the Scientific Advisory Board for OM Pharma in relation to that support. Therefore, everybody will need to judge if I have complied with the obligation of being objective in presenting the data. We probably should go back 25 or 30 years to try to understand what the status of our understanding of asthma was at that time. And basically, if one would like to summarize it in very few words, the idea was that the factors that determine asthma attacks, which are all outlined here in this little picture, plus acute respiratory illnesses, of course, in some way were related to the cause of asthma. In other words, that what triggered asthma caused asthma. I think that was the basic idea. And if we could decrease exposure to these triggers, we would decrease asthma. Now, I'm not denying that there are out there people who are, for example, allergic to only one pollen, and if you were to desensitize them against them or avoid exposure to that pollen, they wouldn't have asthma. But those are more the exceptions than the rule. The great majority of asthmatics, particularly children with asthma, are sensitized to many allergens, and the role in childhood asthma of desensitization is controversial. And the reason for that is simply that there's no single factor that determines the disease. But even with this idea, there were significant efforts to determine, for example, if decreasing exposure to dust could in some way, and to the mite present in dust to whom many asthmatics are allergic, if it could decrease the prevalence of asthma, and those efforts were all not successful. So around the beginning of this century, results like this one from the Tucson Children's Respiratory Study that we have been conducting, which was started by Lynn Tausig and Wright and Wayne Morgan in the early 1980s, it changed very radically the way we understood the causes of asthma. What we found after following children from birth up to, in this case, the age of 14 at that time. Now these participants are 40 years old. What we found was that children who had one or more siblings at home and did not have daycare, which are here in the black triangles, had, as you would expect, since they were exposed to less children, had less wheezing illnesses in early life, and that was expected. But what was unexpected if we kept following these same children, and we're talking about during the first 6 months of life about this exposure, what we found was very paradoxically, at that time considered paradoxical, that they had more asthma later in life. Or to say it the other way around, if you were exposed to children, you had more wheezing in early life, but then less asthma during the school years. And this caused significant attention in the scientific community. Everybody was trying to understand what this was related to. With Patrick Holt, almost at the same time that we were publishing these studies here in Tucson, Patrick is an immunologist from Australia. We were asked by Lancet to comment about this set of studies. I just showed you one of them, the one that we did. And we proposed that the hygiene hypothesis needed to be reinterpreted. Instead of being that infections protected against asthma, which how it was started, we proposed that changes in the type and level of stimulation from microbial environment associated with improvements in public health and hygiene may have indirectly influenced the postnatal development of immune functions. And we postulated, really more speculation than anything else, that variations in the gastrointestinal flora, as you can see here below, would be an important element of all this. Now, the decisive findings were those of the farmers in Europe. Here you see where these farmers, where these studies were done, live. These are, I would say, not wealthy, but well-off farmers. And here is the barn, you can see there. And they live basically on top of their own cows. Still, this kind of family farming exists in Europe. And what was found is that when the prevalence of asthma was compared in these individuals, in these children, with school children of the same age, but who lived in the little villages close to these farms, they had 6, sometimes even 7 times less asthma, depending on what they were exposed to in the farm. And this really was a big shock to many people, because what is it that could be there that in a farm could be protecting so significantly against the development of asthma? Really a completely different way of understanding the disease in these early years of the 20th century. There were some objections to these studies. People said, well, maybe farmers choose to live there because they are less sensitive to the urine or whatever it is that these persons are exposed from the cows, and therefore there's a choice. As those who are more sensitive decide to be postal workers in the little towns, and those that are less sensitive decide to live in the farms. And that's why you see that there's less asthma in the farms, because they're less sensitive people. Well, the solution for this conundrum came from these studies, and here it says Juteritas, that's in Spanish, it should say Hutterites, is the comparison between Amish and Hutterites here in the United States. These are two populations of Anabaptists who came to the United States, the Amish in the 18th century and the Hutterites in the 19th century. And basically they come from the same region in the Alps. They were expelled from there because they were Anabaptists, and they came to the United States at different times. And everybody knows the Amish have kept basically their the way in which they lived in Europe in the 21st century, and therefore they live, as you can see here, on top of their cows. Instead the Hutterites came much later and adopted a more industrial way of farming, and therefore their stables are very far away from where they live. Here you can feel when you're there the stench, I would call it, of the cows, but here you just don't feel it. They're very far away from the cows. And what was found was that the Amish had 4 times less asthma than the Hutterites. So what was found in Europe was confirmed among the Hutterites and Amish here in the United States. And in spite of the fact that both are very dedicated, both communities are very dedicated to cleanliness in the home. They're very traditional in their family structure. They have many children, both of them. But in both cases, women are essentially dedicated to the home. In spite of that, quote unquote, common cleanliness, the Amish were much more exposed to bacteria than the Hutterites. And this was obviously attributed to the fact that they live just where the cows are, and therefore they're exposed to the products of the manure and the stables themselves, and are therefore more exposed to bacteria. That's the way it was analyzed. What was very interesting is that the immune system of these children, we got peripheral blood mononuclear cells from these children. In other words, blood, and stimulated it with different products. And what we found first was that while the Hutterites have more eosinophils in circulation, a marker of allergies, the Amish had more neutrophils in circulation. And that gave us an indication there is a difference in the immune system. But not only on that, I mean, I'm sorry, I'm going to go back. Almost every product of inflammation was increased in the Hutterites as compared to the Amish. It's almost as if the immune system is buffered in the case of the Amish. And this was assessed by exposing these peripheral blood mononuclear cells to stimuli and then seeing how the cells responded. And they responded much more actively in the Hutterites with all these, as you can see here, from IL-17, IL-2, everyone, all these markers of inflammation. Now, this was all very good, but the hypothesis was that this was due to bacteria, but these studies did not elucidate what the bacteria were. And here we were very much helped by the development of a completely new way of studying bacteria. In the past, bacteria were basically studied by culture, and therefore we could find what we knew how to culture and what we knew what it was. And here you see one example. But now we have a way to study the DNA of bacteria. And I'm not going to go into any details in this slide, was not the purpose, but just to stress that we went from culture to genomic methods. And that allowed us to discover that there's something that has been called the microbiome, which is at least 10, if not 100 times more varied and more diverse than we ever imagined, living on us, living in our stools, living in our intestine, living in our mucosas, vaginal, nasal, oral, and intestinal, and in our respiratory mucosas. And we did that thanks to these so-called agnostic methods, in which basically all we do is try to find bacterial DNA, and then we identify these bacteria. And many times we identify bacteria that were completely unknown until the studies were done. And using these methods in the same populations that I showed you before in Europe, that were shown to have so significant differences in the prevalence of asthma, a study of the bacteria in the stools, the so-called gut microbiome, was done during the first year of life. And here you see the composition on the left, the composition of the gut microbiome at the age of 2 months in a population of children that live either in the farms or in the small little villages that I talked about before. And then the same thing at the age of 12 months. And based on the degree of maturation of the microbiome, which you can see very clearly, there are differences. Each one of these lines on the vertical axis is one person, and this is the relative abundance is one person. Yes, and the relative abundance of the different bacteria that you see here on the right. And this at the age of 2 months and at the age of 12 months. So you can see that at 2 months, there's a lot of red, and that red is bifidobacteria. But slowly, a more mature microbiome, as we call it, starts appearing. And this more mature microbiome is represented by these other colors. And here are kids, for example, on this extreme right, that have a much more mature microbiome by the age of 2 months than this group of children. Same at 12 months. So they develop an index of maturity of the microbiome along the way, with the idea that the more mature the microbiome, say at the age of 2 months, the more likely it would be that these children would not have asthma later in life. And they studied what determines the degree of maturity at 2 months and at 12 months in this index that they call EMA that you see here. So to the right is more mature, to the left is less mature. And you can see here in the middle, use of antibiotics, less mature, older siblings. Remember the study that I present to you from the Tucson study, older siblings more mature, cats more mature, growing on a farm more mature, exposure to animals, consumption of raw milk, any cow's milk, eggs, any eggs, all these determine maturity. Smoking determined immaturity. Paradoxically, breastfeeding is associated with immaturity. The children are less exposed to external bacteria, but on the other hand, there's a lot of compensation to this fact by the other extraordinarily important effects of breastfeeding. And what they found was also that the more mature the microbiome at the age of 6 years, the less likely to have many different forms of asthma. Here are atopic, non-atopic, different models and so forth. Basically, the faster you mature the microbiome during the first year of life, the less likely you are to have asthma 6 years later. This is the same population that I showed you before, this one here, and this is the final result of what they had. So maturation of the microbiome is associated with less asthma later in life. This provided an explanation for the fact that the farmers, who were one of the factors that determined maturation of the microbiome, that the farmers had less asthma. But then we needed to know which were the specific bacteria, because the idea was, well, if there are specific bacteria, perhaps we could replace this bacteria in children who don't have them from very early in life, not exposing them to cows, but exposing them to the bacteria themselves. So here in the United States, this is a study done by Susan Lynch and her co-workers from UCSF, together with researchers in Detroit. They did something very similar and found that there are 4 groups of bacteria here in the United States that, when present, are associated with less asthma at the age of 6 years, and when absent are associated with more asthma at the age of 6 years. And they are lactobacilli, bifidobacteria, Akkermansia, and fecalobacteria. We will get back to this in a moment when we talk about therapeutic approaches, but fix your attention to this particular slide. Again, all these circled here is different types of bacteria, and underlined are the bacteria that are more abundant in subjects who are protected against the development of asthma, and therefore less abundant in those who develop asthma. Now, what do we know today about the fact that you have more or less of these bacteria in your intestine? This is a beautiful slide. It's an old slide, but still very actual, very much up to date with respect to what we know today. And what is shown here on the left is healthy bacteria, and on the right, depleted bacteria, or microbiota, as it's called also, in the intestine or in any mucosal surface. So if you have more healthy microbiome here in purple, there's no space, there's no biological space for pathogenic bacteria. And therefore, there is less pathogenic activation in red of the epithelium, and more healthy activation of the epithelium early in life. And the pathogenic is associated with here activation of inflammatory mechanisms. Instead, the healthy activation by the normal microbiome is associated with activation of IL-22 and other protective mechanisms of the immune system. When you don't have here on the right the protective purple bacteria, or they're less abundant, there's much more likely that what will interact with the epithelium are these types of bacteria, the pathogenic bacteria. And they are much more likely to activate inflammatory mechanisms, and therefore to activate in the body as a whole, in the whole of the soma, inflammatory mechanisms. Protective mechanisms on the left, inflammatory mechanisms on the right. And therefore, we should expect that in the airway, individuals who have not been protected and therefore who are more likely to develop asthma will have more pathogenic bacteria. And that is what has been found. This is a study by Biscard, also published, like most of the others I have shown, in the New England Journal of Medicine. And you can see that shortly after we had described this association between siblings and not having asthma, they found that individuals who shortly after birth were colonized with Streptococcus pneumonia or Haemophilus influenza or Moraxella catarrhalis were more likely to develop asthma by the age of 5 than those that were not colonized. In other words, not only here we have shown that not being colonized with protected bacteria is associated with more asthma, but being colonized with pathogenic bacteria is associated with more asthma. And these are bacteria that are known to be potential agents for infections. We'll get back to that later in the talk. Interestingly, when Bill Cookson and co-workers, a good friend of ours and collaborator with us, studied the same thing in adult asthmatics, now not in nasopharyngeal swabs of what you saw before, but in bronchoalveolar lavage of asthmatics, adult asthmatics, here in the outer ring, and compared bacteria in these bronchoalveolar lavages in normal controls here in the inner ring with the same genomic methods, not culture here, but genomic methods that I showed before, they found exactly the same thing that Hans Biscard and co-workers found in newborns. In other words, it was Streptococcus here in green compared with this green here in non-asthmatics, Moraxella compared with non-asthmatics, and Haemophilus compared with non-asthmatics that were more abundantly present in individuals who had asthma than in those who did not. We'll talk in the second part of the talk about the potential clinical and therapeutic consequences of this consistent finding. These 3 bacteria have been in at least 15 studies, including one done by us in the Tucson Children's Respiratory Study, consistently found to be associated with asthma. So I hinted to this before, but just to make it even more clear, the maturation here of the bacteria in protected bacteria in the intestine from almost in utero birth to later life is associated with the maturation here, maturation of the bacteria, and here maturation of the immune system. The 2 things go in parallel. It's almost like we have a new organ unknown to us before here, which is one in which bacteria, you can see it very clearly here, interact with the immune system to produce a healthy immune response that then propagates through a specialized type of T cell called T regulatory cell to the whole body. So this is kind of an introduction, and now in the second part, what I would like to do is to first summarize what I just said, and then to take the therapeutic consequences of what I just said. Is there something based on this knowledge that we can do now to use this knowledge to make the life of our children better, or even to prevent the development of asthma? Is there something we can do now? So in summary, you can see here that insufficient maternal transfer of bacteria, I didn't talk too much about it. There are studies showing that, for example, cesarean section is less likely to produce the transfer of protective bacteria from mother to child, and therefore children born by cesarean section are more likely to develop asthma and allergies later. Or alternate postnatal environmental exposure causes what I have called dysbiosis, which is this excessive presence of pathogenic bacteria and lack of presence of protective bacteria. Here you have it, absence of protective microbes and their metabolites, and excess of pathogenic microbes and their metabolites, the products that these microbes produce that are pathogenic in this case. I showed you what they do to the epithelial cells, or are protective in this case. And so what can we do? Well, one thing, it would be supplementation. I just hinted to that before. Simply, if we know which are the bacteria that are missing, maybe we can give those bacteria. And the other one is what I would call mimicry. I will explain what I mean by that. We could also propose, and you'll see that studies have already been done, to use antibiotics in persons who already have these bacteria, perhaps to decrease the number of pathogenic microbes, with the idea that this could decrease manifestations of the disease. And finally, if I have time, I will talk about this, which is a futuristic but extraordinarily fascinating and greatly promising idea, which is to use genetically modified bacteria. So let's start with supplementation. I showed to you before that there were 4 types of bacteria, and one of them was the lactobacillus that was decreased in children, very young children in the first months of life, who would go on to develop asthma. This was done in the very first months of life. And of course, we know very well that there are probiotics in which lactobacilli are present, and many investigators in the last, I would say 15, 20 years, have tried to use lactobacilli to prevent the development of asthma and other allergic diseases. And this is one of many. There's now an industry that, particularly in China, in continental China, that produce these kind of studies. And this, I think, I reviewed, and this is well done. And what they did is they took all the studies, most of them done by one scientist, that have been done, or 2 scientists that have been done until now, in which specifically in those studies, probiotics were given in infancy, all of them containing lactobacilli, and then children were followed up to the age of 6 years to determine if these probiotics, as compared to placebo, could prevent the development of wheezing. And here are the results. You can see that with just one exception, all the studies were non-significant. The final meta-analysis was, I would say, very borderline. There was only an 18% decrease in the likelihood of developing asthma or wheezing. You can see it here, 0.82 protection, but it was really borderline. And out of this, I would say there's no clear evidence. It's too borderline and too weak to suggest that children out there should be given these products to prevent asthma. I mean, you would need to treat hundreds of children to get one in which you would prevent the disease. So the first type of studies have been disappointing. There's no indication today to give probiotics to prevent wheezing and asthma. Well, I showed you that there were 4 bacteria that were depleted in individuals. Here they are. These 4 bacteria were depleted in individuals with who went on to develop asthma, and they were depleted very early in life. And the investigators that did this study led by Dr. Susan Lynch, developed a product which is based on these 4 bacteria. I have no interest in this product, but I think it's a very fascinating study that they're trying to do, which is called ADORED. And it's the Allergic Disease Onset Prevention Study. It is a phase 1b/2, in other words, phase 1 and phase 2 randomized, double-blind, placebo-controlled, multi-center study of this product, which is nothing more than a combination of the bacteria that I just showed to you, live bacteria, that is being given to neonates and infants at risk for the development of allergic disease. And it has 2 parts, very briefly. Part A, 3 parts. This is to determine safety, and then they're starting now a part B in which they will enroll 224 subjects, in which they're going to not determine the incidence of wheezing, but the incidence of atopic dermatitis in the first phase after 336 days in which they will treat these subjects with this product. In other words, for a whole year, they will treat them with this product. Apparently, this product has been safe because the study has not been stopped, but I don't know more than that. Very exciting idea of replacing with live bacteria, the live bacteria that have been found to be depleted in very, very young children. These children are 1 month to 12 months of age at high risk for asthma. The second aspect is what I here, for lack of a better word, I have called mimicry, and I will try to explain myself. For years, there have been these extracts of pathogenic bacteria that have been either tested or given in Europe, Asia, and other parts of the world, but not in the United States, for the purpose of preventing bacterial diseases associated with lower and upper respiratory infections. And these bacteria, these products contain staph, strep pneumo, Klebsiella, Branamella, Haemophilus, and or Moraxella, which you heard before were some of the bacteria that are found to be inhabiting the airways of individuals at high risk or who already have asthma. These products were tested in the 1950s, but by injection, by subcutaneous injection. And they were found to be completely not associated with a decrease in allergy or asthma in those studies, and therefore were abandoned. Those, if you fix for a moment this because these are the products that I will be talking about in a moment. What is interesting is that after those unsuccessful trials, they kept using orally, empirically, because a lot of people swore that a lot of practitioners swore that they worked, that when they gave them to these children, they had less, and adults, they had less respiratory infections. Most of the studies that were done testing these products until very recently were really not very well done. And they were published in minor journals with a few subjects and not in a well-done clinical trial. Until very recently, 2 of those products, here you see one of them. This is one product that contains these bacteria called MV130. This product is produced by sonication, and therefore the bacteria are killed. These pathogenic bacteria are killed, but are kept as cellular bacteria. They're not lyophilized. In other words, the bacteria are there but are killed. Now, it's important to understand that these products were initially thought to act as vaccines for these bacteria. And you will see that really that's not probably the way they work. But this is one study published in a very reputable journal, the Blue Journal, one of the most important journals in the field of respiratory disease, And they showed that giving these MB130 to children with significant wheezing, these are all preschool children, they found that during the whole period of the trial, which included 6 months of treatment and 6 months after the treatment, there was a significant decrease, here you see in orange, of the prevalence, or in this case, sorry, in this case, incidence of wheezing illnesses in the children who received the product compared to those who did not. In fact, most of those who did not receive the product have had at least one episode, you can see here, whereas the group who received the product had many less of these episodes. Very significant difference between the two. But what was most interesting is what they found post-treatment. This is at the beginning, at this point 0 here is at the moment in which they stopped the treatment. And still, after they have stopped the treatment, there was significantly less wheezing illnesses in the children who had, in the previous 6 months, received the treatment with respect to those who did not. Now, these were all children who had already had wheezing. There was significant wheezing. This study is different from the previous. It's done with OM85, which is also called on bronchovaxum. This is the product we're using in an eagle. And here, the purpose was to prevent the development of wheezing illnesses. So they started the treatment very early in life, in the first months of life, in children who had not had severe lower respiratory illnesses. So these are very young children during the first 1,000 days of life. The study, to be honest and present the data, was negative for the primary outcome. It was small, but was published in this journal, in JACI, which is a very reputable journal, because it showed that for this other outcome, which is an important outcome about which I will talk in a moment, there was a significant decrease, again, decrease in the incidence of wheezing illnesses in the children who received this OM85 with respect to those who received the placebo. And what was most interesting about this study is that in these same children, they studied the immune responses of the children who had received or had not received OM85 or bronchovaxum. And these children were studied before they started the treatment, and after they started the treatment, they got blood from these children and studied as I showed you also before for the Amish and Hutterites now, they studied the immune response of these children. And what was extremely interesting was that the children who had received the OM85 here in orange looked very much like the Amish. Instead, the children who had received the placebo looked very much like the Hutterites. And in addition to that, their immune cells in peripheral blood had been networked, re-engineered to produce more interferon, which protects against viral infections, and had a decrease in the inflammatory networks. Remember what I had told you before, if you have pathogenic bacteria on the surface of your lungs or on the surface of your intestine, you increase the inflammatory networks. But if you have protective bacteria, you decrease the inflammatory networks and increase the protective networks. Well, that's exactly what they found in the children who had received OM85, who, as you saw, had less incidence of wheezing illnesses later in life. So based on all this, we're doing the ORBEC study. In the ORBEC study, this is similar to what I just showed to you for primary prevention of wheezing. This is going to be at the very end, an 8-year study. It's now almost 8.5 years that we have been going on with this study. A significant proportion of the children enrolled in this study were enrolled in at El Rio, in El Rio clinics. And what we did was we basically gave them for 2 years, between the ages of 6 and 18 months, starting at those ages, and for 2 years, either OM85, bronchovaxum, or placebo, and then we're going to assess the outcome during the 3 years subsequent to the 2 years of treatment. In other words, We're not going to include the 2 years of treatment. This is a primary prevention trial. Our idea is that if you receive these products, your immune system is going to be re-engineered and you're going to have more protective genes activated and less pathogenic genes activated. And these are all the centers, including ours here in Tucson, again, as I said before, that are participating in the study. There's a similar study going on called BLIPA. It's not identical. This is a study that is geared towards children who have bronchiolitis. Immediately after they're given bronchiolitis, they are given for a period of 24 months, like we did, bronchovaxum, but the outcome is measured during the treatment, not after the treatment as we're doing. This study is going to end almost at the same time as ours. So there are going to be 2 preventive studies with different target populations that will be completed in the next year and a half to 2 years. And finally, we have the EAGLE study that you know about, in which you kindly are helping us enroll, which is very briefly a study in which we're evaluating OM85 in Wheezy children aged 6 months to 5 years, very similar to the study using the other product that I showed to you before. More details about the study are certainly available. We need to enroll children with wheezing illnesses between the ages of 6 months and 5 years. And finally, in severe asthma, in the Precision network funded by NHLBI, we're doing a study in which 5 products are being tested, new products, completely new, for persons with severe asthma between 12 and 90 years of age. The recruitment is now closed for this study. Some subjects were also enrolled here through El Rio. And basically, we're studying 6 medicines. I want to call your attention that a bacterial extract is also being studied, and it is bronchovaxum or OM85 in a population with eosinophilic asthma and severe asthma. So this is very exciting because for the first time, these products, different products, some composed of live bacteria, some composed of bacteria that are inactivated, some composed of extracts of bacteria are being tested. It is the hope that we will have a completely new way of treating asthma if any of these products is found to be effective. Let me finish with in the last 5 minutes with excess of pathogenic microbes. These other that I have showed you before, especially Haemophilus strep and moraxella, which are found much more abundantly in the respiratory mucosa of individuals with asthma. And of course, the first thought that comes when you see that is to use antibiotics. And the antibiotics that has been mostly used is macrolides. And here is another of these many studies, these many meta-analysis that was recently published. I think this is very, very serious one. And one way of using macrolides with the idea of treating asthma is to use them like we use them in cystic fibrosis. In other words, 3 times a week, Monday, Wednesday, and Friday, for prolonged periods of time. And these are all studies of that type. These are Monday, Wednesday, and Friday, 1 dose of azithromycin or other macrolides and placebo. And here are the results of the studies. Only 1 study has been effective. You can see here the Gibson study in 2017 published in The Lancet. All the others were negative. And for requirement of hospitalization or requirement of an oral corticosteroids or an ED visit, the results were not significant. However, there was a borderline positive result for daily symptoms. But again, there was only 1 study that was significant, the Gibson study. All the others were negative, and the results were not very convincing, as you can see here. There's only 1 done with this other way of detecting daily symptoms, so there's nothing that can be said about it. It's only 1 study with only 51 subjects. Now, the GINA recommendations that we almost all of us use as a guide, not as a requirement, but as a guide, suggest that maybe in some subjects this could be tried based on the Gibson study. It's very cautious. It's not recommending it to be used out there. And I would suggest that this should not be used for us because the data are really not very convincing. And the results are not very consistent. The other way of using it is using during acute attacks. And here is a study done in adults, basically in acute exacerbations. And I don't need to present you a lot of statistics. You can see this azithromycin was used or placebo during 3 days. And then the adults were followed for 10 days. And there was absolutely no difference between the ones to use active and the ones that use placebo. We did also with your help in El Rio, we did this study, which is the so-called April study, in which we gave 12 milligrams per kilogram of azithromycin for 5 days to children with significant history, previous history of wheezing illnesses. And we started the azithromycin at the first signs that usually ended up in a severe wheezing lower respiratory illness in these children. And to make a long story short, we found a decrease of 36% in the incidence of wheezing illnesses in the subjects. You can see here up to the 4th treated episode as compared to placebo. It's not a very strong effect in terms of statistical significance, but it is a strong effect in terms of the decrease in wheezing illnesses. Well, a study was done in Canada in which the results were negative. They gave in the emergency department to children who were already wheezing, so it was a little bit different to what I just showed. They gave them azithromycin. As you can see, the results were very similar for those whom they gave azithromycin and those whom they gave placebo. There were no significant differences between the two groups. This was 222 subjects. The study has several problems. They couldn't enroll enough subjects, so they stopped it before they had enrolled the number of subjects they were expecting, and they gave only 5 milligrams per kilogram, which I think is a relatively low dose. So to do a definitive study in this sense, we are conducting now. We have almost 600 participants enrolled. I am the co-principal investigator of the study in the emergency department. We are giving to children who are either positive for these 3 bacteria or negative for these 3 bacteria, azithromycin or placebo. These are the number of subjects, in a total of over 1,500 subjects. We're going to give azithromycin or placebo, and we're going to measure while we're giving the azithromycin, the severity of the disease in these children. These were children, these have to be children that are quite severe. In fact, 44% of these children until now have been hospitalized. And we continue giving them the azithromycin or placebo while they're hospitalized in these ED centers all over the country. So I think this study will definitely answer the question, is azithromycin effective in the treatment of preschool children with severe wheezing episodes? Is it is it effective in everybody, regardless of if they have these bacteria or they don't have these bacteria? Or is it only in those who have the bacteria? And therefore, I think what we want is to be able to guide practitioners to using or not using these products. If the study is negative, it's going to be important because we will say clearly and unmistakably, please don't use them. But if the study is positive, we will have probably a new tool, particularly for the children with more severe disease. Finally, in the last minute or so, let me go very fast through this because this is the more futuristic aspect. This is what you will see maybe 10 or 15 years from now. And what you will see is genetically modified bacteria. This is already happening in animal models. And there are 3 ways of doing this, or maybe 4. One way is that you remove some native function, in other words, in pathogenic bacteria. So you remove a function in the bacterium. Remember, I showed to you those red bacteria that activated inflammatory processes. And now what you're going to do is you remove them, you've removed the native function, and you basically flood the intestine or even the airways with these inactivated bacteria that are going to be there and that are going to overwhelm the pathogenic bacteria, much like it naturally occurs when children are exposed to bacteria in early life. The other possibility is to engineer a function to create active protective bacteria, engineering them. And therefore, here they are in green, and they are balancing the pathogenic bacteria in the same way that it is done naturally. This has already been very successful in animal models, and I know that there are small companies that are trying to develop this for the treatment of diseases such as asthma. Another way would be similar to what I just said, but not doing it engineering the bacteria, but engineering phages, which are viruses that infect bacteria, and activating in these bacteria through these viruses positive responses, as the ones that I showed before, done through bacteria. And finally, the last slide. This is just quite extraordinary. This is almost, I have called this the second domestication. It's basically to create a, how could this be called? A guardian dog in a bacteria that will have a system that will sense the inflammatory responses in the epithelium to bacteria, will immediately activate a gene through this sensing that will transduce and respond with the green ones. Remember the green ones, the protective bacteria, is to create ad hoc protective bacteria. This is also being studied in animal models, and it is very much at the initial phase, and it's extremely promising. Well, we will have probably in the future here on the right interventions that will allow us to use all we have learned about the role of bacteria in protecting and causing disease to decrease the suffering of the many children who suffer from asthma all over the world. Thank you so much.
Oh, wonderful. Thank you, Fernando. That was really excellent. So I'm going to ask Desiree to please disable the forced mute on our attendees, and people can enter questions in either the chat or they can turn on their microphone as we get you set up here for live questions.
There's already one question. How do they deliver, I think, how do they deliver the replacement bacteria? The replacement bacteria are delivered by mouth. These are given with a obviously masked product, either the bacteria or the placebo.
So I have a question about how you might use monoclonal antibodies that would specifically target the bad bacteria to take out the bad guys and leave the good guys. Is that being tried?
No, but it's a very good idea. I mean, if we could treat bacteria with anything that is not antibiotics, in a certain sense, what you're proposing is to target specifically the bacteria that are pathogenic without at the same time targeting all the other bacteria, including the protective bacteria, because that's the problem with antibiotics. Antibiotics are never specific for one bacteria. They always affect other bacteria. And we're all worried about increased resistance. there is no evidence that 5 days of azithromycin increased resistance. We are studying in the AC sweat study that I showed before, we're studying the development of resistance. So we will know if 5 days increases it. So in the next 2 years, we'll have the answer for that. But we do know that using it Monday, Wednesday, and Friday increases resistance to azithromycin. That's already established. So if we could have a product that acts specifically on bacteria, would not only be good for this, but also for pneumonia, for all the other diseases that are caused by specific bacteria. Is there data to show benefits for sinuses as well as lungs? There is evidence of benefits for allergic rhinitis. And it's not very good. It needs to be tried better, but there is evidence for allergic rhinitis. And my hope is that this could also be useful for sinusitis, which is, as you very well know, strongly related to allergic rhinitis.
Is the mic working?
Yes.
So that was a superb talk. I mean, I've heard you give it in different sections. It's just delightful, just delightful.
Thank you. Thank you.
So obviously, at least of the three, pneumococcus, H-flu, and Moraxella, for some time now, we've immunized children against Haemophilus and pneumococcus. Have people looked at the impact of that? Because there were different eras of onset in different countries. Has ISAC looked at that?
It is very interesting. Your question is very interesting because we are conducting the AC sweat study that I talked about before. And this is in children up to the age of 5 years, all of whom, or most of whom, hopefully should have been vaccinated at least for pneumococcus. And we're seeing exactly the same prevalence that have been found in those that are not immunized. I think the immunization acts for the how could you say, for the
invasive
illness,
disease.
for the illness.
Yeah, invasive disease. It prevents
invasive disease. But the stuff that is floating there in the mucus, it really has no effect on it. Most likely, I'm speculating here, so don't quote me on what I'm going to say now. Most likely because IgA mechanisms, for example, are not activated.
Right.
So you activate the IgG mechanisms and the IgM mechanisms, but you probably do not activate the IgA mechanisms, which are specific for the mucosis. But that's a speculation.
Yeah. And the other thing is, there's a pretty good relationship between small intestine bacterial overgrowth syndrome and asthma. More common in atopic asthma. You think that that's a reflection of, and as Dr. Gashan always points out, the lungs are just a mere appendage of the elegant gut. And I always point out that the lungs are the finest evolutionary advance of the gut. But the bottom line is the lungs are gut. Do you think the linkage there makes you wonder as well about that dysbiosis and how those two are pulled together? Because it's striking that you'd have that high a rate of SIBO in asthma, particularly atopic asthma, as high as 2/3.
What we're finding, Wayne, is that many of these inflammatory diseases are related between them. You have, I'm going to give a different example than one you gave, but you have insulin resistance is associated with asthma. Mm-hmm. And diabetes becomes an inflammatory disease. So all these diseases that are associated with dysregulation of the immune system in one way or the other have been linked to changes in the microbiome. However, and thank you for giving me this opportunity. However, these are only association studies. What we absolutely need the clinical trials because we have been fooled before by association studies. So, and the clinical trials are really going to solve the problem. That's why I think it's so important to study like AC Sweat, the one in the emergency department, or the clinical trials that you or I are involved with, including EAGLE. They're critical to really get to the point in which we can say, yes, these are causal factors for the development of the disease or for the development of attacks. Please comment on the interaction between certain viruses and bacteria And thank you, Rita. Yes, I showed even too many slides. So, but a very good friend of ours from the University of Wisconsin, Jim Gurn, showed something very, very interesting, which is that what triggers these acute attacks, both asthma and wheezing in preschool children, are viruses. It's not bacteria. But the individuals who have the bacteria are the ones who have the worst attacks, or the more likelihood of having the attacks. And that suggests, as you are hinting to, that it is the interaction between the inflammation caused by the chronic presence of the bacteria and the acute insult of the virus that really may be causing the worst disease. And therefore, there is the hope that if we can eliminate the effect of the bacteria, the inflammatory effect of the bacteria, we may be able to make these attacks less severe or to prevent them. Now, you can do that with antibiotics, which is the least effective way, because you are also killing many other things and developing resistance. Or you can do it by increasing the number of either live bacteria or bacterial products that stimulate the protective mechanisms that I showed during my talk. Somebody raised their hand.
Yes.
SAAHC.
Say heck, yes. I have a question in the chat. I think I'm the only one that can see it, from Dr. Rajiv Modak, and I'm going to pronounce something wrong, so forgive me. As pathogenic bacteria like pneumococcosis may contribute to development of asthma, would we have expected to see a decrease in incidence of asthma with the advent of pneumococcal vaccination in infants?
Yeah, that's what we were commenting about before, and we can, with Dr. Morgan, and we can reiterate it. It appears that these vaccines have an effect on invasive disease, but do not have an effect on non-invasive commensal nature. Let's call it quote unquote commensal. When they're there, but they're not producing disease. They just stand there. They survive there and are activated by the virus.
Okay, well, maybe we can take one more question.
I have here. Oh, there are no more questions in the chat or in the Q&A.
Well, we are at the end of the hour, and thank you again, Dr. Martinez, for your elegant lecture. I really enjoyed that. The lecture will be posted on the SAHEC website shortly, so if you want to see it again, you can. And you should be given in the chat the link to the SurveyMonkey. I see it's been posted, and to register that you have attended, and to give feedback on what you liked or didn't like about today's performance, please go ahead and take the survey. And thanks again, that was delightful.
Thank you so much, Andrew, for the invitation.
All right. Good evening then. Thanks everyone for attending. Much appreciated. Thank you, Desiree.
You're very welcome, and I will be sure to distribute the slides tomorrow to all of our participants, along with a reminder about the survey.
Okay,
All
so
right.
I will get, each of the attendees will receive a copy of the slide deck, correct?
Yes.
Wonderful. I'll
Yes.
look forward to reviewing that again. Okay, I'm going to take the survey, and I'll let you go.
Thank you. Have a good evening.
Yeah, take
Bye.
care. Bye-bye.